Let us look at this second example. They are saying calculate the mass of a gas with a density of 2.615 grams per cubic decimeter at 298 kelvins and 101 Newton per meter squared. So remember, we have two formulas. However, of course, we have two formulas, PV equaling to nRT and PV1 P1 over T1 equaling to P2 over V2, P2 times V2 over T2. So we won't be using this, but we will be using this because this question is not, it's actually not comparing with the standards. We just have quantities of this expression. So let's go ahead and manipulate and obtain the molar mass. Remember that to obtain moles n, we divide a given mass by its relative molecular mass m, or the molar mass m, which is the area of interest. So our PV becomes this when we substitute, and then RT. We need to make the molar mass the subject. So when we make it the subject, we have m equaling to the mass given, RT, divided by PV. This is the new expression that will help us obtain the value of the molar mass. Okay, basing on the density is given us density is equal to 2.615 grams per cubic decimeter, meaning that for every 1 cubic decimeter there is 2.615 grams of that gas. So we need to consider in terms of cubic meters, because the pressure provided to us is in terms of meters, areas in units of meters. So we need to focus on volume in terms of units of meters. Therefore, we know the relationship between 1 meter, 1 cubic decimeter is equivalent to 0.001 cubic meter, holding 2.615 grams. So what about 1 cubic meter? This will hold 1 divided by 0.001 times 2.615 grams. So ideally, we'll have our new density equivalent to 2.615 divided by 0.001. This is now grams per meter, or for each cubic per cubic meter. For each volume, each one volume holds this mass. Okay, let's now compute. So our mass becomes this is the mass for every 1 cubic meter. So we'll have 2.615 out of 0.001. Then we are going to multiply the value of R, which is 8.314. Then temperature has to be in Kelvin, which is 298. Then everything divided by the pressure, which is given as 101, times the volume provided. The volume, of course the volume is one for every cubic meter. Okay, so we go ahead to compute the mass. So after computing all this, plugging this in the calculator should give you a value equivalent to 64.2 as the mass. Here you don't need to put okay, molar mass, you can put grams. Yeah, that's the answer. That's how we compute it.